Good day, viewers. In today's tutorials, we are going to look at cells. Alright, now cells as a topic is very important so far as elective math and core math are concerned. Alright, so before that, let's understand this sign. So this sign is seen as positive square root. So anytime you see this sign at this topic, for instance, in case you are given, let's say, root a, this one is taken as the positive square root. All right. Now, before we can understand the definition and the meaning of cells, let's understand perfect square. All right. Now, 1 times 1 is 1. But when we take positive square root of 1, we get 1. All right. Now, let's analyze this very well. So 1 times 1 is 1. All right. So if we take square root of 1, okay, we get 1. All right. Now, let's look at the next one. 2 times 2 is 4. Now, when we take square root of 4 to give us 2. Okay. Now, let's look at the third one. 3 times 3 is 9. Now, square root of 9 is 3. All right. So guess the next one. So 4, 5, 6, 7, 8, 9. All right. Now, these numbers here are called perfect squares. Perfect squares. Now, when we take square root of these numbers, you get exact values. There won't be any decimals or point or what have you. So it will give you exact values. So these numbers are called perfect squares. All right. So for instance, 10 times 10 is 100. Okay. Now if you take square root of 100, it will give you 10. So with this, 100 is a perfect square. All right. Now let's look at these numbers. Now pick a calculator and let's verify this. Now we have this, that, and this. Okay. So if we take square root of this 9, give you 3. Okay. Then 25 will give you 5. So get 64. Okay. So what is square root of 64? So verify this. All right. Now these numbers are giving us exact values. So they are called perfect squares. Now let's consider those that will give us decimals. Now if we take square root of 2, now let's look at square root of 2. Okay, square root of 2, 1.41. Okay, 1.4142. So. Now let's look at 5, square root of 5. So we are getting 2.2360. Now let's look at square root of 7. It's also giving us 2.6457. I've not a few. Now these numbers that are not giving us exact values, they are called cells. So they are called cells, and they are also called irrational numbers. And those that are giving us exact values that are the perfect squares are rational numbers, because they can be expressed in the form of a over b. Okay. Now these numbers are also prime numbers. So most of the cells are prime numbers, most of them. So we have 2, 5, 7, 3, 11, they are all prime numbers. So these numbers are all prime numbers. They are prime numbers. Okay, so if you take square root of any of them, it won't give you exact values, and these numbers are all sets. So square root of 17 is a set, this one is a set, so they are all sets. All right, now that we know the definition, the meaning of sets, let's look at reduction form. So all right, so if root y cannot be reduced further, then it's said to be in the basic form. So with reduction to basic form, in case you are given a question, let's say 18, and you're asked to simplify this one, you need to reduce this one to its basic form. Now, once your answer is in the form of set, for instance, 3, okay, something like this, so you can get something like 4 with 3, 5 with 7. They are all in their basic form because we have sets here. Okay, so that is that. So let's look at examples. All right, so pay attention well. So we are going to look at the following examples. Okay, so we know the meaning of set. We know perfect squares and what have you. So let's simplify the following. Now before that, let's list their prime numbers. So we have 2, 3, 5, 7, 11. Okay, and on my right, let me list perfect square here. So 1 times 1 is 1, 2 times 2 4, 3 times 3 9, 4 times 4 16, 5 times 5 25, 6 times 6 is 36, 7 7 49. So in that order. So these numbers are considered as perfect squares, and these ones are also prime numbers. Okay, so we are going to simplify this one. So we want to write this one in its basic form. Okay, now that's what we are going to do. So we will start by dividing this 75 by the prime numbers here. Now, it's not always that we use prime numbers, but 90% of the questions works with this. All right, so let's start with 2. Now, 75 divided by 2, it won't give you exact number. So once you divide this one by this and you don't get exact number, it means you are not taking that. Make sure your answer, when you divide this one by any of this, you get one of this. That is the perfect squares here. Okay, so 75 divided by 2 is giving you 37.5. So we are not taking that. So 75 over 2 is giving us 37.5. So we are not taking this. Now let's move to 3. So 75 on 3. So 75 divided by 3 is giving us 25. Okay, so 25 is a perfect square. Check this. It's a perfect square. So we are taking this. So we use 3. Then the answer is 75. So we are going to change this 75. Okay, so 75 is 25 times 3. Okay, so this 25 is a perfect square. Make sure you get perfect square inside it with sign. So 25 is a perfect square. So 25 times this is a perfect square. Okay, now let's record something here. In case you have A times B, that the root sign is the same as A times B. Okay, so this one is the same as 25 times 3. Okay, so this one is a perfect square and we know it's 5, so 5 times 3. Okay, now in case you have, let's say, a times b is the same as a b, so this one will be 5 3. All right, so we say this one is in its basic form. Okay, so that's the answer. All right, now let's look at the next example. We have 18, so let's try this. 18, so let's divide 18 by 2. Let's see, 18 by 2 is 9. Okay, 9 is a perfect square, so we are using that. So 9 times 2, that is a perfect square, so 9 times 2 is same as 9 2, so we have 3 with 2. Of course, if you take square root of this on your calculator to give you this, you can verify. All right, so let's look at this. 98, then 200. So let's pause the video and try this. So take your time. 2 3, the upper numbers 5 7. Okay, it's not always that we use the prime numbers. Okay, but these questions work for 90% of the prime numbers. So 2 3 5 7 11. Okay, in that order. So let's start with 2. Now 98 divided by 2, yeah, so 90 divided by 2 is 49, and 49 is a perfect square, so we are taking 49 times 2, so 49 is a perfect square, so 49 is the same as we have this and that, so have 7 times 2, so 7 with 2. Now if we take square root of this, it will give it this, so we say this one is equal to that. Okay, so let's try this. Square root of 200. Yes, so pause the video and try this. All right, so let's divide this by 2, so we have 100 times 2, that is 200, and 100 is a perfect square, so say 100 times 2, so we have 10 2, that is all right. So let's look at addition and subtraction of sets. Addition and subtraction of sets. Now we can only add or subtract sets which have the same form. Now let's consider this. Now number 1, okay, we have, let's say, a with k plus b k. Okay, now we can only add this because we have the same form here. Okay, so let's check the root sign. We have root k here and root k here, so we can add the coefficients. So we have a here plus b, then we pick one of the radicals here, so we have k. Okay, so in case we have, let's say, 3 5 plus 7 5, so we have this one to be equal, so I'll just add the coefficient, so 3 plus 7 root 5. So 3 plus 7 is 10. So we have 10 root 5. Okay. So we have 10 root 5. Okay. Now, in case you're also given, let's say, 2, 7 plus 7. So straight away, since we have this, got that. So we have of the same form, so we can add the coefficients. Okay. Now, if this side were to be 6, there's no way we can put them together. All right, take note. 2. Okay, we have A minus B. So we have this and that, but they have the same form, so we can subtract. All right. So we have A minus B. Okay, all right. Now let's note this down. Now note root 7 plus root 2 is not equal to root 9. Don't think this is 7 plus 2. No. So this one remains the same. And also root 7 minus root 2 is not equal to root 5. Don't say 7 minus 2. No, this one also remains the same. All right, now that we know the conditions, let's number 1. So pick a paper and your pencil and let's solve the following. So 3 root 5 plus okay, so let's solve this together. Now we have root 5, root 5, root 5. So we can put them together. So we have 3 here. So let's write. So plus 2 plus 3. So 5. So 3 plus 2 plus 3 is 8. So we have 8, 5. Okay. So example 2, 4, 7 minus. Okay. So we have 7 here. So we can subtract. All right. So we have 4 here. We have minus 3 here. So let's subtract 4 minus 3 root 7. So 4 minus 3 is 1. So this one is more or less 7. Because 1 times that is that. So it's 7. Okay. So the next example is root 3 plus 5. Now these ones are of different forms. So the answer remains the same. So we have root 3 plus root 5. Okay. So example 4, 2 root 5 minus 5 root 5. Okay, so this one are of the same form. So we say 2 minus 5 root 5. Therefore, 2 minus 5 is minus root 5. All right, so 14 root 7 minus root 7 plus root 7. So try this one. So you can send the answer under the message box down there. So 14 root 7 minus root 7 plus root 7. All right, so thanks for watching, and don't forget to subscribe for the next video. So we are going to look at some examples of these and that things. Okay, thanks for watching, and I'll see you in the next video. All right, so